Hello and welcome back to the System Design series. In this video, we will learn how design goals can be categorized and which design goals are associated with each of those categories. Further, we will learn what does each of these design goals mean and how we can optimize them for our system. Before we move further, let me recap the summary from the previous video. We learned how we can follow a three-step process to identify design goals from the functional and the non-functional requirements. We also learned that we may not be able to achieve our design goals 100%, but rather, based on the trade-offs, we should design a system in such a way that we work on optimizing each of these goals. At a very high level, we can categorize the design goals in 5 different categories. Performance. This category of design goal helps us to make our system more performant so that a system can scale as our user base grows. Dependability. This category of design goals helps us to make sure that a system becomes more dependable and reliable from an operational standpoint. Cost. This category of design goals helps us understand the various costs that are associated with a system and how we can keep the cost in check. Maintenance. The maintenance category includes a set of design goals that deals with the ease with which we can maintain our system. End user criteria. This set of design goals helps us understand certain key constraints that will help us increase the overall user experience, which will eventually lead to more adoption of our products and services. I hope you got a high-level overview of the classification of design goals. Now let's see what design goals falls in each of those categories. Performance. The design goals in the performance category are related to speed and space requirements for a system. Let's look at some of the key criteria in this category that will help us define performance-related design goals. Throughput. Throughput refers to how many tasks the system can accomplish in a certain amount of time. For example, let's say we are a payment processor. We provide an API that allows our clients to charge the credit card of their customers when they want to capture the payment for an order that was made by the customer. If our system is able to support 100 such requests per minute, this essentially defines the throughput for a system. So throughput is nothing but the amount of things that we can get done in a fixed amount of time. In another example, let's say a system processes payroll for employees of a company. The throughput in this case can be defined as how many employee payrolls we can process in 1 hour. Now, this payroll processing time is a time-bound activity. That is, it needs to be completed before a certain time in order for us to make sure that the employees get their salaries. As new companies and employees are onboarded to our service, the total number of payrolls that we have to process by this due date keeps on growing. Due to the extra payrolls, the throughput of system can go down, or even if it stays the same, we would have to either start early to finish in time or process more payrolls in parallel to make sure that we can get all of that done successfully by the pay date. So a design goal should be that the throughput of a system and a service should be high. We can define a number to quantify it and then measure the performance of our system against it. Response time. Typically, system response time is defined as the time between when the user initiates an action and when the computer starts to display the results. This is answered by the question, how soon are the user requests acknowledged? We want the response time to be low, implying a service is acknowledging and responding faster. Let's apply the same concept to an API that is exposed by a service. The response time would be defined as the amount of time it takes for an API to process the request and send the response back to the client. The response time period begins when the client initiates the request to the API server and ends when the client receives a response from the API. Generally, APIs that are considered as high performing have an average response time between 100 milliseconds and 1 second. We want to design a service in such a way that it responds faster to the request, and we can resort to that by caching and other techniques. Our design goal should be such that the response time from a system should be low. Like throughput, we can define a number to quantify it and then measure the performance of the system against it. Memory. The next criteria is memory, which is the amount of space that is required to run the system. We need space to store all the user-generated data, the application metadata, and other kinds of data. Likewise, we need space to store the computed data and look up the computed data very quickly to improve the user performance and make our service more responsive. The space here could refer to both the temporary memory like RAM or the disk-based permanent storage like the hard drive or the SSD drives. We want to optimize the design goals to reduce both the temporary and the permanent memory footprint, but in certain cases, for performance reasons, we may choose to compromise on memory so that we can optimize on the throughput and the response time. A classic example is to cache the API response to improve a response time, leading to more throughput. However, since we are caching here, we would increase the memory footprint. Another example is to create a materialized view in the database and query it rather than running a join across multiple tables. In both cases, we increase our memory footprint, but we improve our response time and also increase our throughput accordingly. As system designers, we have to review our requirements and make those trade-off choices in order to build an optimal solution. That's all for this video. In the next video, we will cover other design goal categories, namely dependability, cost, maintenance, and end user criteria. Please subscribe if you have not done so that you can get notified when a new video is released. Till then, keep learning. See you next time.